Good afternoon, ladies and gentlemen. I'm very glad to be here with you and trying to try to explain you what we're doing for smart grids. And smart grids, whether we are industry, utility, distribution utility, or even citizens, are going to impact or are impacting already the way we operate, the way we behave. And I would like to show you concrete examples on how connected technology can help to solve the issues and the challenges of the smart grid. So I will briefly introduce Schneider infrastructure, and then I will give you those concrete examples and present the major stakes we have in the electricity distribution aspects. And then I will finish with a couple of innovations we have that are enabling all these technology to happen. So Schneider infrastructure, we are present, medium voltage energy distribution is present in all segments of industry. Buildings, data centers, wastewater, all of these industries, mining, minerals, are using medium voltage energy and need distribution systems. Obviously, distribution utilities are the enabler of all these medium voltage energy to be distributed and brought to the factories. In terms of footprint, we are very balanced between mature countries and developing countries, new economies. With approximately 50-50. Next slide, please. So, making a smart grid a reality, we are providing solutions from the upstream, the generation, into the transmission and distribution aspects, but also on the consumption side. And that's what I would like to show you. The main drivers impacting the electricity, medium voltage energy distribution, first of all, the aging of the networks. The infrastructure is aging. In mature countries, in new economies, constraints on the budgets are high everywhere, or almost everywhere. And that means we cannot renew as fast and with as much capacity as it would be needed. On the other end, we see the rise of renewables. Fossil fuels are not available forever, or will not be available forever. So we have to move on, and we are moving on to renewables fuels. On the other end, this is also accompanied by more stringent regulations. For instance, in Europe, we have 3 directives with reductions in increase in efficiency, increase of renewables, reduction in carbon emissions. So all this mix is really pushing towards renewables. On the other end, there are still some investment. So the sector is growing. There are some investments. And this is mostly because we are expecting a huge increase in energy consumption. See, projecting by 2035, plus almost 40% of energy consumption overall. Next slide, please. So in this context, what are the main challenges of the utilities? Well, first of all, is ensuring the grid stability despite the complexity. So I don't know for how long you can tolerate or think it's bearable to have a shutdown of electricity, a blackout. Depends on what is your activity, but most of them it's critical, so it's intolerable. Apparently, in the US, the public says it's tolerable for 6 hours, which is approximately the length your smartphone can last. And after 6 hours, it's totally out. So, but anyway, this is needs to be restored much quicker for industries or for even for areas where people live. So why complexity? Well, basically, in the past, you could imagine the generation and the electricity network with large centralized production units coming down, top down, in a unidirectional flow. Now you have renewables dispatched in the whole territory. So the flow is multi-directional, bidirectional in most of the place. And on the other hand, renewables that are much less controllable than traditional energies. So the stability, the control of the grid is much more complex than it used to be, and it's going to increase as more and more industries are also going to produce their own energy from renewables and maybe inject that into the grid. So another one, please. So here, for instance, I want to show you a solution we have provided to one of our customers. This is in Spain with 9REN, which is a company, an engineering company providing this solar farm. So one of the challenges we have in renewable energy is the cost of this energy and the complexity to control these sources that can be very scattered. So here we have provided a control system that enables to control almost 600 locations with one operator, one control system, and it enables to be much more efficient in all the planning, the maintenance planning, and the control system of the energy. So you see that with that, we are turning an energy which was difficult to control and to monitor into an energy which is much more dispatchable. Another aspect of the smart grid is the microgrid. So microgrids are growing and growing. It's a way to isolate a part of a grid, and the better example is what happened in physical islands. So here we have an example in the Faroe Islands. So we have built, along with our partner Dong, we have created a complete integrated system that enables to manage the grid. So it means basically monitoring all the sources of energy, all the consumptions, the stability of the grid. So thanks to all the connected solutions, we're able to manage this microgrid, and this is leading to lower fossil fuel consumption to produce this electricity, higher stability, and cheaper electricity in the end. Another challenge is to increase operational efficiency. So, for instance, in Europe, we need to increase efficiency by 1.5% per year. So we need to do that not only at the end of the chain with the consumers, but also in the process. So one of the solutions we have is to be able to increase the flow of energy in a given network, which means running closer to the limit of the network. So for instance, here we have a solution that is in a city in the Netherlands. Unfortunately, we're not allowed to tell the name of the city, but that's a large city in the Netherlands. We have installed a self-healing grid. So a self-healing grid is a grid that is enabled to detect automatically some defects and reconfigure in order to minimize the impact of the defect. So here we were able, there was a cable which was cut by a storm or physical incident, and the network was restored in 18 seconds. On average, this kind of restoration would have taken 2 minutes before we install this system. So you see, we're able to operate closer to the limit of this grid, which enables to increase the capacity of energy that is transiting through the grid without putting additional cables and switchgear. Another aspect is the generation of energy. So here in this reaping power plant, we have installed a system which enables to manage the energy of the plant and also to control the whole process through our structureware software suite. So basically here, by monitoring the various production areas and monitoring the flow of energy, we're able to be much more efficient. And you see there was a saving of over 20,000 tons of CO2 emission. Another aspect we have in making smart grids a reality is to manage the demand. So we have seen that we have on one side the generation, the injection of renewables. On the other hand, to manage the grid more efficiently. The third pillar for us is to manage the demand. So we have here an example, another one, please. So how do we handle peaks? So you know that electricity consumption is not linear in the day. In the morning, when everyone is getting up and using a domestic appliance, there is a peak. Then there is another peak at the end of the day when everyone is coming home and also managing the home. So those two peaks, or more peaks depending on each profile, if we weren't managing the demand, they would need additional generation. By managing the demand, we are able to shave those peaks and to avoid to generate more electricity. How do we do this? For instance, with Energy Pool, we have aggregated several industrial customers that are consuming energy, and their capacity is, they have a huge capacity to consume energy, but also to shed some load at a given time. So we manage the process for them not to be too much impacted by this reduction of the energy consumption at one time. So that's our know-how, and it enables us to really cut the consumption of these customers by 20–30% compared to their peak consumption. This gives a virtual generation capacity for which we don't need to build a new power plant or to increase the generation, because we're able during this peak period not to consume this energy. So, well, I showed you how our connected technology enabled to monitor, manage the grid in a smarter way. Just in a nutshell, basically the areas we have been talking about: grid operations, which is manage the network efficiently, operate closer to the limit of the network; renewable operation, which is to make renewables dispatchable and more usable; microgrid, which helps to limit the dependency on fossil fuels, but also increases the grid stability; and last but not least, the energy services that are helping to bridge the demand and the supply, talking together more in a smarter way, more cleverly, in order to minimize the need for generation. So all this also works because we are building devices that are already ready to be connected. So here we have two devices. First of all, our PremSet switchgear, which is a totally new isolation media, and it's revolutionary from this standpoint because it's a solid insulation instead of gas or vacuum insulation, so it enables to be much more compact. It's also a design that is already built in to be connected to the control systems. And mineralized grid is a transformer that can be adjusted while being on load. So it enables long reconfiguration when you want to adjust your transformer. So it enables, again, to be much more efficient in the way that the grids are used, and for them to be used in an optimal way. So you can discover these on the booth. They are there. So I think, I hope I've really illustrated how these connected technologies can help to manage the grid in a smarter way. But if you still have some question, I guess we are going to answer all those now. Thank you very much.